Hey guys, welcome back. Today we are going to talk more about stationary points. I realized last lesson I kind of showed you how to identify whether or not stationary points are local maximums or local minimums, which we're going to do more of today. But I'm going to actually show you how to find the actual coordinates of them and how to find absolute maximums and absolute minimums. So we'll just say the lesson today is more stationary stuff. Okay, just a little bit of reference about what this one problem I'm going to do with you guys today is about. Let's say you had some sort of graph. Let me make it up. That it was like something like this. First up, these spots here are local maximums, and this spot would be a local minimum. But then there's questions about whether or not there's an absolute maximum or minimum over a certain interval. So I think you're going to have homework problems where they tell you to look at the curve between a certain x range. So let's say that you were only looking at this function from here to here. And they asked you to find like a local minimum and maximum. Let's say we went more over to the right. You could use derivatives and stuff to find those stationary points here, like this guy, and this guy, which we will do more of today. But then if you think about the maximums and minimums in terms of the y's over that purple shaded region, do you see how this spot right here, like on the curve, is higher than this spot right here, that this is lower than that. Like if you look at the y values that are associated with these, like this y value is less than this y value. So the problems today are going to give you this sort of range where you have to check the endpoints. So if they say like only look at the function from here to here, then you would be like, okay, I'm only looking at the function from here to about here, and then you have to check these endpoints here and here to see if they're bigger or smaller than your local minimums and maximums to check if they're absolute minimums or absolute maximums. I realize that was probably very confusing the way I just explained all that, but I think through the problem, it will make more sense when we're actually doing it with the problem. Okay, here we go. First example today. We're working all with this function f of x is equal to x cubed minus 45x squared plus 6 hundo x plus 20. The first task, find the stationary points. And we're going to find the actual coordinates of the points. Find the stationary points and label them as local maxes or mins. Okay, first step. We're going to use that derivative to figure out where the stationary points are. So f prime of x is equal to 3x squared minus 90x plus 6 hundo. And that's it. Then remember the stationary points are where the slopes of the tangents are 0. So you can set the slope machine equal to 0. 3x squared minus 90x plus 600. Now you got a gnarly quadratic on your hands, but they're all divisible by 3. So you can go 0 is equal to x squared minus 30x plus 2 hundo. Now we need to figure out two numbers that multiply to positive 200 and add the negative 30. Because 200 is positive and the negative 30 is negative, you know they both have to be negative numbers. And I believe it's negative 20 and negative 10. Which means you get 20 and 10. Now, what should we do first? Let's figure out the actual coordinates. We know that the x values happen at 20 and 10, but I want to know what the actual y values of the coordinates are. So what we're going to do is take the OG equation, the cubic up here, and we're going to plug in 20 and 10 to figure out what the y values are. Probably going to grab a calculator for this. So f of 20 equals 20 cubed minus 45 times 20 plus 600 times 20 plus 20. So let me see. 20 cubed minus 45 times 20 squared. Forgot the square. My bad. Plus 600 times 20 plus 20. So that's, oh, it's 2020. Hey, the craziest year ever. So f of 20 equals 2020. So that means that the coordinate of a stationary point is 20, 2020. Let's do the same thing with 10, that if you plug 10 in, we'll get 10 cubed minus 45 times 10 squared plus 600 times 10 plus 20. Remember, this is in the OG equation. Let me just copy pasta. Whoops. No, get that. And maybe replace these all with 10s. All positive 10. That is 2,520. So f of 10 is 2,520, which means that the stationary point is 10, 2520. Now, I know those are stationary points, but I don't know what types of stationary points there are. So we have to do a zone test. 10, 20, we only got 3 zones this time as opposed to last lesson where we had 4. So we got to test this zone, and this zone. I'm going to choose the numbers 0. 0 is always a fun one. What do you guys think for the in-between? Should we go 15? Smack dab in the middle? Doesn't have to be in the middle, just anywhere between 10 and 20. And I'm going to keep it small and do a 21 over here. Now, 0, 15, and 21, we're not plugging into the OG equation. We're plugging it into the derivative because we need to know what the slopes of the tangents are doing in those zones. So the derivative back up there is f prime of something is equal to 3 times something squared minus 90 times something plus 600. Put a 0 in there, and you definitely get a positive number. Put 15 in there. Let's see. 3 times 15 squared minus 90 times 15 plus 600. Negative number. And then 21, you get a positive. So if you think about what's happening with the function, let's do it in orange, make it pretty thick. That means when we plugged in a 0, we got out a positive number. So it's going uphill in this zone, then it's going downhill in this zone, and then uphill in this one. So what that means is the coordinate 10, 2,520 is a mountain. Because if you kind of picture this curve, like I'll connect the dots here, it probably looks something like this. So when you put in a 10, that's the top of a mountain. When you put in a 20, that's the bottom of a valley. So that means that this guy is a those are too big. That this is a minimum, but it's a relative minimum, or local, relative or local, those are both interchangeable terms. Relative minimum, and then that this guy is a relative maximum. So that's the first part of this problem, that this stationary point is a relative minimum, this stationary point is a relative maximum. The second part to this that I didn't write down yet. Did I even say this was part A? Yes. So part B is find the coordinates of the absolute maximum and absolute minimum. On the interval 0 to 30. So here's what's happening. Absolute means like the biggest y value, biggest or smallest y value that's on the curve. Now, if you were to graph this, you would see that the arrows go to positive infinity and negative infinity. So if they didn't restrict it, if they didn't give you this right here and just asked for the absolute max or min, it would be positive infinity and negative infinity. But because they restrict it on that 0 through 30 only, that means we have to plug in 0 and 30 into the OG function to see, first of all, to get what coordinates would be associated with that, because both of these are x values. This is like an x to an x. We need the y values that go with them, and then we're going to check if those y values are bigger or smaller than these y values here that were on the stationary points. So let's see. First, we need to plug in f of 0 into the OG equation, which is something cubed minus 45 something squared. So this will be 0 cubed minus 45 times 0 squared plus 600 times 0 plus 20. So that is 20. So that means the coordinate, when you put in a 0, you get out a 20. Now 20 is way smaller than 2020 or 1520. So that means that this is an absolute minimum. It's the smallest y value that you're going to get on the graph in between 0 and 30. So that's an answer right there. Now that whole process we just went through, we have to check for the 30 as well. So we have to put in f of 30 is equal to 30 cubed minus 45 times 30 squared plus 600 times 30 plus 20. I believe when you plug that all in, you get 4,520, which means that when you put in a 30, you get out a 4520. Now, is 4520 bigger than both of these numbers? Yes, it is. It's way bigger, which means that that is the absolute maximum. Oh, I guess I should write that in purple. Now, there will be times where you plug in the interval endpoints and those numbers aren't bigger or smaller than the stationary points. So then the stationary points would become an absolute value or absolute maximum or absolute minimum, which I think does come up in your homework examples. You guys, we're still plugging away with 13.5, but we're still not going to do all of it. I'm just going to give you the next couple problems because 13.5 is just a massive section. Next week, we'll start talking word problems with derivatives.